Okay, good morning. So today I will talk about some of the lessons learned that I have from customers who are building PaaS platforms on Microsoft Azure or multi-tenant PaaS platforms. So these are from my perspective, which is from an architecture and a developer perspective, and not an IT pro or ops person. So first of all, again, I'm Tom Kerkhove, I work for Correlate. I already did the disclaimer, so I'm not going to say everything's a best practice. It's just what we've seen was either good or not good, and it's up to you to decide if you agree or if you want to do that at the customer as well. So I'll start with one of my most favorite topics, which is scaling things. And we have a couple of versions of that. The first one is the traditional thing we did back on-prem is scaling up and down. So based on the needs, you basically just went and got a bigger box which runs the same thing, but that means that that application becomes unavailable because you basically need to change the infrastructure that it relies on. Now there's a problem because at some point you will not have a bigger box. So at that point, you'll have to basically find a better solution. So a more cloudy way of doing things is basically scaling out and in. Basically, you add multiple copies of the same application, which means that you will not really have the downtime. You can add as many instances that you want. But the downside, again, is that it becomes more complex because you have to have the traffic routing if it's HTTP, for example, and your application needs to support this. Now that's the theory, but scaling also depends on the compute infrastructure that you rely on. So when you pick the compute infrastructure, you implicitly also pick the scaling approach that you will use. For example, with Azure Functions, it's very easy to get started, but you don't have control over how it scales. Is that okay for you or not? That's up to you. But it basically defines how you will run, package, and scale your application. For example, here with the serverless application, basically you just add a few lines of code, and then the Azure Functions scaler will automatically add more instances when the work starts to pile up. Very simple, okay? So the good thing with this is that the service scales everything for you. Now, the bad thing is the service scales everything for you, because if you want to influence that scaling pattern, you basically really can't, or it's either putting a maximum amount of instances on it or something, but you cannot control how aggressive it is. In some scenarios, that's fine, but in certain scenarios where maybe you're writing to a SQL database and that database is getting flooded, well, bad luck. You have to keep it into account because you cannot do the scaling. Another very bad thing is that because they do the scaling, your bill can become very high, and I'll come back to that later. Actually, no, this is the one already. There are a lot of scenarios where you see this, that, hey, we started doing serverless, and then in Monday, I saw that we basically got a bill for thousands of euros because we had a bad implementation and it was constantly scaling. I don't know if it was this case, but there was somebody who had an Azure function, which was triggered for every new blob that was on the storage account. They basically did some work, updated the same blob, and hey, the same function was called again because you updated the blob, which means that it's a new blob, and basically they created their own scaling loop. So it's tricky. Now, you can have more control with PaaS, where basically, in this case, it's cloud services. It's still alive, so you can still use it, where you basically create an order role, and you have one instance. That instance then dequeues the messages, and then you can use an autoscaler, which basically says, hey, if we have more than n messages on the queue, we should start adding more instances so that we can basically react to the workload. So basically here you already have more control because it's up to you to define what the scaling rules are. Okay, that's great. But also that means that it's up to you to define what the scaling rules are. And it's very hard to define the perfect scaling rules. Now, you will certainly not get them correct from day one. You should see this more as an constantly learning pattern for you, and you will constantly be tweaking those scaling rules. And that's also why the scaling awareness is very important. Where, for example, with Azure Monitor, every time it performs a scaling action, they will emit a webhook, and then you can basically post those webhooks to Slack and see, hey, we're scaling. And we've seen that that's very interesting because at a certain point in time, we had a scaling rule which was bad, and we had an infinite scaling loop. Luckily, it was capped until 20 instances, but we saw that in 10 minutes, we went from 1 instance to 20. If we would not have that scaling awareness, we would have lost a lot of money for nothing on the queue. And then the flapping is an interesting concept. There's a good article on that, but basically it says that if you define that you want to scale up when CPU is 90% and you want to scale down when CPU is 70%, that's basically flapping, because by the time they scale down, the CPU will already be higher again, and it will add a new instance. So it's constantly removing, adding, and then Azure Monitor will basically say, not going to remove it, I know I should remove it, but by the time it's gone, we have to add one anyway. So yeah, you should definitely read those best practices to avoid these scenarios. And then, of course, we have Martin's most favorite topic, Kubernetes, which is a cluster platform as a service, in my opinion. So basically, we have a cluster with multiple nodes. We have different workloads running on top of it. In this case, the blue app and the green app, and they both drain a queue. And if you want to scale those workloads, you need to have a horizontal pod autoscaler with a custom metric provider, which basically then sees, we have messages to process. We should add more. Now, the tricky part is because we have a cluster, we also have to scale the cluster. So you have to have a cluster autoscaler as well, which basically adds a new node, workloads get rebalanced, and then we can add more nodes. Now, the interesting part is you also have to manage, operate, and scale the infrastructure for that scaling. Now, there's also a new concept, which is virtual nodes, which basically allows you to overflow your workloads to ACI, which is a good thing, because then basically you're starting to mix serverless with the cluster platform as a service. But again, be careful, because since it's constantly overflowing to ACI, that means that you will pay for all of that. So again, if your autoscaling is wrong, you'll burn a lot of money. So, summary of the cluster platform as a service. It's a great way to share workloads across the whole company. With virtual nodes, you can make it a bit more serverless, but it brings a lot of responsibilities. And autoscaling is one of them, but also understanding how you should autoscale takes a lot of time, investment, training, etc. And it becomes a lot more complex. So, of course, you could say, hey, you could use Kubernetes Kubernetes event-driven autoscaling. It's vendor agnostic, cloud agnostic, and it has scale down to 0. We can focus on the app, and then instead of this, we have just one component anymore, and we can see that as the workload decreases, our resources also decrease. So this makes it better, but you still have that underlying infrastructure to manage, which for a lot of customers is still a pain. And like we said in the panel, maybe you don't need all of this. You can just use a PaaS. Okay. And then, when workload comes back, we just add in more instance. So basically, it always comes down to use the tool that fits your needs. Do not just go to a service because you've already used it and you know how it works. Always evaluate the options. Every trade-off has its pros and its cons, and you should learn them. And it comes back again to tomorrow. You should not over-engineer because you might need it. If you might need it, then maybe you don't need it at all, and certainly you don't need it now. So you can still change that later on, and I'll come back to that at the end. So to come back to the awareness, this is super important. You do not want to burn all your money. And gaining insights in your auto-scaling is super important. Now, depending on the flavor of scaling that you're using, it will be different. Like with Azure Functions, there is a metric nowadays for that. So you should also have an alert. If, for example, you see that your typical pattern is maybe 1,000 execution an hour, and suddenly you spike to 3,000, is that normal? Maybe, maybe not. So dashboarding and alerting is your friend. And you should not wait with auto-scaling until you're in acceptance or production. You should already do it in develop and test, maybe with lower criteria, lower instance counts, but you should already learn what your scaling is doing. And it's called the metric function execution count. If you're looking it up, it's very well hidden in the Azure portal. And basically here you see that I had a function which was called on a frequent pattern, and here you could then detect the outliers if something goes wrong. What I did mention is resource consolidation pattern really doesn't work with auto-scaling, because basically you scale the whole unit. So you don't always want to scale everything as part of that unit, so you have to make your trade-off. And making and configuring a maximum instance count is certainly something I can recommend. Another thing is you can also auto-scale on business metrics if you need to. Application Insights is a great way to do that. So you should also check if you can use that. And certainly have a look at Azure Monitor Autoscale, which basically does most of the autoscaling that you need, but only for a certain set of Azure resources. But it has scaling rules, it has scaling history, so you can also see the history, you have the webhooks. So from my standpoint, it basically has everything that my customer needs. Okay, tenancy. Who has built a multi-tenant application before? Okay, fair amount of hands. So if you will ask what is multi-tenancy, you will get a lot of questions that you should ask at the beginning when you start doing that. You will not be able to answer all of them, or maybe any of them at the beginning, because you don't have all the information, but yet you already have to make the decision. So that's a very tricky thing. And also maybe today multi-tenancy will be a different approach for the customer than in 1 year. So that makes it really hard. But a lot of people think it's always about the data side, but it's more than that. For example, if we have a look at how will you host your Azure resources, will you basically create a copy for every customer, which has let's say we have an API and a database, will we spin up a new web app and a SQL for every customer? Or will we have one front end and a shared data layer, which is multi-tenant? Or will we have multiple stamps, which is not tied to one customer, but it has a collection of customers on them with a shared database layer? So this is already something you should be thinking about. And also, depending on your scenario, you'll have to pick one or the other. For example, I had a customer who wanted to build a multi-tenant application, but the data had to be siloed because it was insurance information, but they wanted to have one shared runtimes, let's say. So they went for the middle one because it has the data isolation, but all the rest is shared, because that's a bit more easy than the one on the right, for example. Now, data sharding is also a very interesting topic. I will not go in all of the patterns, but basically with sharding, you're going to spread all your data across multiple databases, and based on the sharding key and the strategy that you use, you will determine where the data is located, and you will have to look them up. So this is a very hard thing to decide which pattern you should use. Going back to the scenario here with my insurance customer, we basically went with a very simple data sharding approach, which I will show here. Basically, we will have a shard per customer. So basically, the customer name is the shard key. So here, let's say we were processing an order queue. The order processor would say, hey, I see this is for customer Correlate, so we'll just go to our shard manager. It's in this case Cello. The shard manager asks, hey, where is the shard located for Cello? It will use Key Vault to just use a convention-based lookup, say, hey, give me the secret tenant Cello. And then it will return the connection string, and it will basically connect to the 7th shard. This is the most basic approach, but for some customers this already works. And the shard manager here is just a code library on top of Azure Key Vault, which works actually pretty fine. So basically the shard managers are just your catalog of all your shards to determine where you should be looking. And if you're adding a new shard, they can also basically create the databases on the fly, etc. So you can write them yourselves on top of Azure Key Vault. There's also the Azure SQL Database Elastic Tools by Microsoft. They provide a lot out of the box. Back then, they did not support Azure Key Vault, which was why we didn't use it. You had to have a database with all your connection strings in it, which you should not do. Maybe today they already support Key Vault, I don't know, but that's a good alternative. Now, if we have a lot of databases, that means that we have a lot of Azure consumption. In this case, we have 8 of them, and we see that not everybody is getting the most out of the pricing tier. So we all have S1s, and the most usage is 50%. So we pay around 200 euros for 160 DTUs, and the average is only 20%. So this is not good. So what you can do is use an Azure SQL Elastic Pool, which basically moves all the shards in one SQL pool. We basically assign compute to the whole pool, and then the pool assigns the resources to who needs them. So basically, it's a better way to share the resources. Now, sharing is also tricky because let's say 7 is very, very busy, and then 4 comes around and says, hey, I need more resources, but we're already at the maximum of the pool. That means that one noisy neighbor can basically impact others. Okay? Now, one mitigation is to ensure that every database has a limitation, regardless of the pool. So let's say we have an elastic pool of 200 DTUs. We can assign a maximum on every database, which is 50. So in this case, shard 7 will be capped at 50. And if it needs more, then he's out of luck because we're just avoiding that he impacts all the rest. So that allows 4 now to get more resources than the others. Another way of doing things is you can also create multiple pools, because let's say that number 7 still needs to have more resources and 50 is not enough. We can move him to a more, let's say, that this customer is one of our top priority customers, so we'll assign more resources over there. We'll increase the capacity for the pool and the limitation, but the other ones are still at a lower tier so that we pay less for them. And if you're a platform, this is a great way to also reflect your billing model. So let's say that we have the basic customers who pay 50 euros a month. They can basically go to the basic pool, but they only get 50, and the pool has 200, while the platinum customers get 1,000 DTUs assigned in a pool of 5,000 DTUs. I'm just saying random numbers, but they basically get more resources for the amount that they pay. They can't impact each other, so you're basically segregating your data according to your business model, which is also a very good way. So, as a summary, if you have a lot of shards, you should consider elastic pools. You should put maximum consumption limitations per database to avoid that they impact each other. And multiple pools are a great way to reflect your business model and reduce the noisy neighbor thing. You should obviously not only monitor your database, but now you should really, really, really monitor the pool, because if the pool runs out, everybody runs out. So it's also somewhat of a single point of failure on that front. So alerts are your friend. Now, if we have that whole approach, we also need to know what the shard key is, okay? Now, we found that an API gateway is a very easy approach to do that. So let's say that I'm creating an order and I'm using my API management API key, which is ABC. Then API management knows, hey, in this case, it's Bill Brackett with API key ABC, who's part of the Cello group. And then we just add a header internally, which says this customer is Cello. Then we go to the shard manager and connect to the correct database. And it's just this line of policy in API management. This is a very simplistic way, but if your last mile security between the API gateway and the physical API is secure, then this is a valid way of doing things, certainly if you have VNets and all of it in the mix. So it's a very pragmatic way of doing it. Now, monitoring. Who's a developer and likes operations? 3, 4 hands. So the typical thing we used to do was we spend all our time on an application. When the application is finished, we throw it across the wall, and then ops is like, yeah, everything looks fine. We're good to go. Everything's running stable. That's not what we want. So monitoring is a shared responsibility, but the hard part is you only know how good and important it is until you've been a developer who's been doing the ops side as well. So I've been lucky to be in that place as well. So now I'm forcing all of my developers to also do that. And one of the things is that they should not only write unit tests, they should also have integration and automated tests running on the live Azure infrastructure. And the whole reason is that they cannot attach the debugger to figure out what's wrong. They have to rely on the alerts, they have to rely on the telemetry and the dashboarding to know what's wrong. If there's an issue, they need to fix the telemetry first if they do not know enough about it, and then they fix the issue. And by the time you then hand it over to operations, it's already better. I'm not going to say it's perfect. It's already better for them. Of course, if you can, make one team and don't have the separation, but that's a different story. Now, telemetry is very important, and you can add a lot of information to that, which helps troubleshooting. And correlation is one of the most important things over there. You should correlate all your telemetry, return all the correlation headers to the client of the API, so that if they open a support case, they can specify the correlation ID. You should have different layers of correlation, and you should have a consistent terminology. Okay? If you can, you should also add app-specific contextual information, like if you're creating an order, what's the order ID, what's the customer, etc., etc. But do not include personal information. It's super easy, but you should not do that. So let's say we have, again, an order API, and in the backend, it basically persists it in the database. And we have some asynchronous process. So I first do a list of all the products to see what I will buy. and then I will create an order, which is basically queued and done with a async processor. Now, if we add correlation, there's the first layer of correlation on the operation ID. So it's a single operation which basically gets an ID and returned to the client if they're interested. They don't need it, but it's just FYI. And then the second layer is on a session/transaction level. So basically, on a functional level, what we did here was we just had a look at the catalog and we created an order. So we might be interested in this whole operation, in this whole transaction. So we have a second correlation ID for that. Now, when we start processing that message, we basically go to the order processor. It tries to store it in the database. That goes wrong. So the message goes back to the queue. We try again. Second attempt works, and we're good to go. Now, what we found is that we added a third level of correlation, which is what we call processing cycle ID, which is unique on a individual message processing cycle. So that if we want to troubleshoot the first attempt, then we only see the telemetry for that. Otherwise, you have to plow through all the telemetry and split it manually. While with this ID, it's just done automatically. And Application Insights does a great job of splitting the telemetry for you. Then health checks are a very easy way to know what's going on, but also to verify your deployments. And if you're using autoscaling, health checks are a must. Okay, so basically it tells you, is my application ready to receive traffic? And second, is it still working as it should? Okay. However, if you have health endpoints, certainly if you do not probe them, you should add rate limiting. Because people like health endpoints and they decide, let's ping them every 10 seconds or 1 minute. I mean, you don't have to probe it every single second. So you should add some throttling on top of that. So that basically the health endpoint doesn't become the reason why it's going down. Okay. You can go as far as you want. I always start with a very simple one, which is just this. Do a get, just return OK. So it's an endpoint you can call. And then over time, when you have information about your dependencies, you should also include the information. Nowadays, .NET Core has good support for health checks, so you should also have a look at that. But if it's hard to, let's say, get it prioritized on the backlog, just do something like this, and it's a good start. It's better than nothing, basically. Now, handling alerts is also something that's been fun, let's say. You should always, obviously, automatically create them and automatically handle them. And Logic Apps is a great way of doing this. But it's not because it's more of infrastructure for your app that you should forget about the design patterns. So what we've seen is that using the adapter pattern is very, very essential. Because in this case, we're using Azure Monitor. They decided to change the alert contract a couple of times. And we had to basically create a more advanced alert handler. And then we said, we'll create an adapter for every flavor. We map it to an internal format. And then we have a centralized alert handler, which does everything it has to do. But you should also keep in mind that if you run it somewhere, in this case we use Logic Apps, what if the Logic App doesn't work? What if Logic App has an outage? Then basically your whole operation goes down. So make sure that it's high available or that there's an alert on the alert handler. So yeah, sounds funny, but you'll find out when it's too late that you don't have it. There's actually nowadays a template for that in Logic Apps. So root cause analysis, it's also typical ops thing in my opinion, where it's always good if, let's say, the developer spent half a day figuring out what an outage was, on their dev environment, they should also use the same approach. And the whole reason is not because we need to have an RCA. The reason is that it's good for people to, like I mentioned yesterday, to try to explain to their teammates what was going on and have the whole trail of how they diagnosed stuff. So they can learn from each other and also take action on the lacking points of your infrastructure. But you also have to follow up on those action points, because it's great if you define them, but if you don't do anything with them, it's useless. And then the last sentence is one of the most important ones. There is no such thing as failure. It's only an opportunity of learning. So you should really use a no blame culture. If you see that it's broken because my colleague did a change, pull request got merged, it's fine. I mean, we're all responsible. There's no such thing as failure. So just help each other out. Just try to prevent it in the future, basically. Who's using webhooks in their application? Okay, a couple of folks. Who's providing webhooks externally? Okay. Also a couple of people. Okay. So, webhooks are always fun, in my opinion. And then certainly if you're using things with a generated URL. So if you create a logic app, for example, it creates a very ugly URL. And if we would use that for receiving webhooks, that's great, but what if I accidentally delete that resource and say, whoops, it's gone, I'll quickly redeploy a new instance, we'll recreate it, and then we come back with a new URL. Basically, your whole application is broken. So an easy way to do that is to use a nice DNS name. If the service supports it, like Azure Function does not support that. Logic Apps does not support that, unfortunately. So that's already something you should keep in mind. An alternative is an API gateway. Another reason why you should use an API gateway is security. Let's say we have a fully secured API, it's using mutual TLS. Well, good luck with webhooks, because no webhook provider supports that as well. Typically, it's either fully anonymous or a authentication code as a query parameter. Now, one thing you could do is expose that one webhook operation anonymously on this API, but then you're basically opening up the whole API, making it vulnerable. So an API gateway is good in this case. So what you can do is basically go to the API gateway, which then forwards it internally to our logic app or our more secure API. And you can, with most API providers, you can use query parameter authentication. So basically, when you configure the webhook, you add their API key in there, and then they basically can call your API. And another benefit is what I mentioned yesterday, is that because we have an API key, we also have the analytics of how frequent are they calling us, and are they abusing us or not? And then you could also take according mitigations, like we could throttle them based on API key, for example. But also, if we decide to move things around, like I showed yesterday, we can do that. Now, webhooks are fun, but webhooks can also be a pain if they are not user-friendly. So you should allow, when you are exposed, well, how should I say? If you have customers who can subscribe to your webhooks, you should allow them to provide metadata. The reason is that it's a typical decoupled process. So if we receive a webhook from you, we need to know what the context is around that. And a scenario is, hey, we have an insurance product where we basically insure you when your flight is delayed. So we basically create a webhook for that flight. And when there's updates for that flight, we basically have to check, is it delayed or not? And if it is, then we have to issue a payout. But if we get random flight information, we would have to query all of our customers to see who is applicable. But if you can provide context during the registration, we can say, hey, we want to be notified if my flight to Brussels is delayed. And by the way, this is for customer XYZ with policy ABC. And then we can have better lookups. And having CRUD APIs is also an important one. A lot of them have just the UI, but we had the case where we did a rollout. We did bad webhook registrations, and luckily there was a CRUD API, so we could script the deletion of those. But if you don't have them, yeah, basically you have to go through them manually, which is a pain. Again, correlation here, if they surface their correlation ID, you can include it in your telemetry to contact their support or have the full end-to-end telemetry, basically. And an invocation history is also very easy. If you have to troubleshoot integration issues, then you know what's going on and you can fix that, basically. So if you're providing webhooks, you should think as a webhook consumer, not a publisher, because the way you will provide them will be different. And another problem with webhooks is that we're going to spaghetti infrastructure 2.0, where everything's decoupled, calling everything basically, and you don't have any oversight. So over time, it will basically be a mess. And there's a lot of bookkeeping to do, like who's calling who and who should get which webhook, et cetera, et cetera. So every service has to implement that themselves. And there's no central place to see who's interested in what, basically, okay? And also you have to build in your own robustness, like if we're pushing webhook to the payment service and they're unavailable, we have to build in retry, how long do we retry, et cetera, et cetera. And also we need to be able to verify if certain people own the domain so that we're not going to DDoS them, let's say. So one approach is an event router, and yeah, Eldert already talked about one yesterday, which is Event Grid, which basically does everything for you. You should just publish your events, and then the subscribers who are interested will create a subscription, and Event Grids handle that for you. Okay, so they do the bookkeeping. You have the central hub that does retry, does verification for you, and you have the full decoupling. Now that's good for internal webhooks. External webhooks is a bit harder because of the webhook validation that was mentioned yesterday. You could force your customers to become compliant with Event Grid, but then you sort of have a technology lock-in. I know that Cloud Events is going to look at defining a common way of handling these things, so then it would maybe be better. Because, yeah, with event domains, it's basically just webhooks in a multi-tenant scenario. But it's not there yet. But it's certainly interesting to have a look. Another dirty approach that we were thinking about was, yeah, we'll just use Event Grid, and then if we have to call customer A, instead of configuring their URL, we will add an intermediate logic app which just forwards to their URL so that we don't have the verification handshake, if it makes sense. So it works, it's dirty, up to you if you want to do it. We didn't do it. So just a couple of tips still. They are not durable, so keep that in mind. If you have transactional workloads, think very carefully if you want to use webhooks. And something we've seen that was very interesting was if we publish a webhook to our customer, we always store the copy of what we pushed so that in case of a dispute, we can say, hey, we pushed this information, you gave us this reply. And then they basically didn't have a reason to complain anymore. The global registration thing is also an interesting one. Instead of having to subscribe to all flights, we want to subscribe to an individual flight, which makes it as a user a lot easier. So we don't have to basically drink from the fire hose and do all the splitting ourselves, but you, as a webhook publisher, does it for us. Rate limit your webhooks, and webhooks are also contracts, so version them, provide good documentation, and make them user-friendly. And cloud events is a good way for creating contracts, which is basically now an industry standard, let's say, for webhooks and events. So I would highly recommend that. And do not underestimate the power of webhooks and events internally. So we were building applications where we had to collaborate with multiple teams. So basically, we started emitting webhooks and events internally, and then the other teams could subscribe to those rather than having the tight coupling and the tight release cycles internally. Now, events. So a couple of years ago, actually, it's already 2018, there was a NuGet outage because of a certificate that was expired. We've all been there, I think. And now with Event Grid, this basically all goes away, right? So Azure Key Vault now has Event Grid events. They are still in preview, but they're already there, which basically tell you if your certificate is going to expire, you should regenerate a new one so that you will not be NuGet in the future. If you're using secrets, also works with that. So like what we're working on now is we are basically caching the secrets in memory on the hosts because Key Vault has ridiculously low rate limiting. But if we see that the secret was updated, we have an asynchronous process who detects that. We basically evict the cache, we get the latest version, and we're good to go. Now that's going to be part of Arcus that Sam mentioned yesterday, so if you're interested, you can just use that as well. So should we use webhooks for all the things? No. It's also very important because some people tend to do this, but you should not. Again, pick the approach that fits your needs. Now, one of my most favorite topics is embracing change. And it's because we have to. So in the past, when we were still on-prem, we had these nice release cycles where every couple of years there's a new full version. In the middle, we had a couple of feature packs, and we were basically able to choose when we want to upgrade. And we saw that there was more stable releases. So they used to do the stable releases, but they had a hard time of shifting the product focus. So they basically wanted to be a snail, which was super. So basically, they wanted to go super fast, but they were super slow. And then Agile came along, and everybody said, "Yeah, let's ship to production every day, a couple of times, and we'll do the DevOps way," which turned to be DevOps. Because you are not Netflix, you do not get to do DevOps in one day. Doing DevOps is a culture thingy, and you need to have the full organization in the same mindset to be able to do that. Am I saying DevOps is wrong? Oh, certainly not. It's a lot easier. But you need to prepare yourself for that. You can start very small by just removing all the manual interventions and automating those. You can create automated release pipelines to ship your software. Deployment rings are a good way of shipping it to multiple customers, where, let's say, you first do it to the early adopters, then to the most of them, and then as last part, you do the most important customers who should certainly not be impacted. And then infrastructure as code is also a great way of doing that. But you should not just say, let's start doing DevOps everywhere. It's a whole transformation that you have to go through. Okay? But we live in a world of constant change, and the infrastructure that we rely on is also constantly moving and changing. And I think if we have a look at how Azure changed over the last couple of years, it's more than an example of that. So they are competing to become the first to release a new kind of service, which means that they have to go really fast, and staying up to date has become a hard thing to do. So Who knows one of these technologies here? Who used one of those? Yes, now the hands are starting to get raised. So if you've used it, then you know that it's no longer there. And a service has a typical life cycle. So we start with the private preview, where there's a rough version of the product, and it's shared under NDA with a limited group. So that's always good to know what's coming, but you should not spend too much time on it, because maybe it's not going to see the daylight. Then they go to public preview, where they publicly give it to everybody. Maybe there's a small set of customers first to which they give it, but it's publicly mentioned, and then everybody typically get excited because it's the new hot thing, so we should all use it, right? No? Exactly, because it's still tricky, because not everything that's in public preview is going to stick around. So at that stage, I would say it's good to start playing with it. It's good to evaluate the options, but be wary, okay? And then things go GA, and it's covered with an SLA, and it's fully supported, and we're good to go until they deprecate it. So there are three teams of deprecation in my end. So there's the official deprecation, there's a reincarnation, and a silent deprecation. So official deprecation is, if you're lucky, there's a public statement, hey, this is end of the line, this is where it stops, and you'll have to migrate before then. And you have a nice date, hopefully reasonable, which is not always the case. Then you have the reincarnation, say, hey, we have this nice service, which is a better version of the previous one. This is super awesome, you should all use this. And then the other one dies. That's, in my opinion, the least of, yeah, that's the best one to have, let's say it like that. Because there is an alternative that they've built. Hopefully it's feature parity. It has feature parity, but it's not a guarantee, okay? And then the last one is the most fun one. It's still around. There's no investment. How long will it be around? We don't know. So here are a couple of examples. So cloud services, is it dead? No. But there's no investment. But also keep in mind that it's not only your infrastructure that your application runs on. Like Azure DevOps deprecated their whole cloud-based load testing in 2018, I think. They did a very good job on explaining the why, the what, who's impacted, what are the alternatives, and how long do you have. But it's still something to migrate off of. And certainly in this case, it has less value because it's just part of your tool chain, but you still depend on it, okay? So when you're starting to move away, immediately start planning for it, and get additional help if you need to, but certainly do not wait until the end, because then, yeah, you're too late. So you have to choose an alternative. So there's a couple of ways. So you can use a proven technology, which is maybe older, or you can use the latest shiny. So we will all go for the right one, right? Nope. Maybe. Again, it comes back to use the tool that fits your needs. If there's an older, less sexy thing that already does what you need, or you can use the latest shiny, which maybe does the same, but it's still in preview, or it's not battle tested yet, then I would go for the other one. But maybe the new one has things that you want to have. It depends. Use the tool that fits your needs and decide as a team. You should not have one person who decides, we'll use this, and you have to now implement everything on top of that. No, that's not how it works. You have to have the buy-in from everybody, otherwise there will not be a commitment from the team. And there's still the build or buy question. You can still decide, do we build our own version? But there is no silver bullet. A couple of questions you can ask. What is the learning curve? And should we go there? Is it feasible? Do we have a vendor lock-in? Is it operable? Does it have a future? Sometimes you only see a tip of the iceberg in the good or a bad way. Something might look very nice, but it turns out to be different from what you expect, or something that you thought was really awful might be a good thing. And that's why app portability is essential, right? So you can prevent yourself from being impacted on a couple of levels. So like, if you write your code in .NET Core, it already works on Linux and Windows. It's a good thing. In the past, we only had Windows, which decreased our portability. If you package it as a container, you can run it on different runtimes. If you use something that's called open application model, you can deploy that container on any infrastructure without you having to know how that works. Eventing and webhooks use cloud events. You could also, like Sam mentioned, use the event grid specific schema, but then you have a lock-in with event grid. With cloud events, you don't. And if you do service-to-service communication, you could say, hey, we'll use a service mesh and we'll use Istio. But if you focus on the specification behind all of these service meshes, you can basically say, Istio, imagine Istio is going away, we'll use something else now instead. Because you do not have the lock-in, you can very easily port your application. And the open application model is basically an abstract way of defining your application according to 3 personas. Like I, as a developer, can say, you need to run this Docker container, and it needs to have a connection string as an environment variable. Then someone else can say, okay, we'll run this container, but it will need autoscaling on top. And then the third guy will say, okay, this workload, we'll run it on Azure or Kubernetes or whatever. So basically over here you see that because we use the open application model, it supports multi-cloud, edge, and on-premise. Because we have just focused on the description of the application, and then the runtime, which is an implementation of this, can run it. And some of the implementations today are Kubernetes, Alibaba. Since Azure started the whole initiative, they will also probably have something. I don't know. I hope so. But basically, if this would get adopted, it would allow you to basically decouple fully from the infrastructure. And I have to go back because yesterday the service mesh interface was opened as a proposal to be donated to the CNCF, which basically makes it even more open, and the adoption will only increase. So to sum up, you learn by doing, and sometimes you will regret your choices, but that's perfectly fine. Just learn from it and move on. Nothing is set in stone, and your platform will never be finished. We built that platform in, I think, 1 year, and in 1 year we had to migrate off of 3 things without any business value, without us being able to prevent it, but we had to do it. So we had to change architectures and stuff, but there was no other way. But you have to prepare for those migrations. They are never fun. You'll have to learn new stuff. You'll have to retest because maybe assumptions that you made were wrong. Change is coming, so you better be prepared. If you want to stay up to date on Azure deprecations, it's a pain. So I started collecting all of them on a GitHub repo, which includes services, features, APIs, SDKs, and even regions, because this year they're deprecating US Gov in Iowa, I think. So you can follow it on Twitter or on GitHub. And if you see any deprecations which are not listed, just open an issue. But Azure is working on this to make it better. So there's hope. Conclusions. I'm not going to go through all of them, but basically think about the technologies that you use because they impact your infrastructure, how you scale, and make sure that you thoroughly spend time to see if they are really what you need. Provide user-friendly webhooks, use API gateways, automate all the things, and you build it, you run it. I don't know who said that, but that's really a good phrase. It doesn't mean you have to run it in production, but certainly internally in the testing, focus on that telemetry, alerts, dashboards, etc. And we live in a world of constant change, so be prepared. And with this, I'd like to thank you, and if you have any questions, feel free to ask them or come over.